More on chemical reactions. To further understand chemical reactions, it's important to know the difference between exothermic and endothermic reactions, as well as the role of catalysts. Chemical reactions can either release or absorb energy, which determines whether they are exothermic or endothermic. Exothermic reactions release energy to the surroundings, usually in the form of heat, making the surroundings warmer. Energy is usually given out in the form of heat, so exothermic reactions involve a rise in temperature. The best example of an exothermic reaction is combustion. This gives out a lot of heat. It is very exothermic. Many neutralization reactions and oxidation reactions are exothermic. Everyday uses of exothermic reactions include hand warmers and self-heating cans of coffee. Endothermic reactions absorb energy from the surroundings, usually in the form of heat, making the surroundings cooler. Energy taken in is usually in the form of heat. This heat energy gets converted into chemical energy. The drop in heat energy means that the temperature of the reaction mixture falls. Endothermic reactions are much less common than exothermic reactions. Thermal decompositions are a good example since they involve a substance taking in heat and breaking down. Everyday uses of endothermic reactions include sports injury packs. A catalyst is a substance that speeds up a chemical reaction without being consumed in the reaction. Catalysts work by lowering the activation energy needed for the reaction to proceed, making it easier for reactants to turn into products. How catalysts work. Lower activation energy. Catalysts provide an alternative reaction pathway with a lower activation energy. Not consumed. They are not used up in the reaction and can be used repeatedly. Increase reaction rate. They make the reaction go faster without being part of the final products. Catalysts are very important for business, and most industrial reactions use them. By increasing the speed of the reaction and lowering the temperature needed, they make industrial reactions cheaper and increase the amount of product made in a given time. There are some disadvantages to catalysts. They can be expensive to buy, and different reactions use different catalysts, so businesses can't get away with just buying one to use for everything. They also need to be cleaned, and they can be poisoned by impurities. Understanding these concepts helps explain why certain reactions happen spontaneously while others need external energy, and how catalysts play a crucial role in both natural processes and industrial applications.